Welcome back, everybody. We have just a little bit more to do in this section. We just have one more concept, really, and then we'll spend the rest of the time doing this little worksheet. If you're watching just the recording, feel free to email me, and I can send you a copy of the worksheet. And before you comment on it, yes, I know in question 3 that one of the numbers is off center. I pressed print without looking. And I had accidentally pressed a tab on that line. I was trying to change it to be organized in centers, and I either tabbed or I didn't do that one. I know, and it drives me. It's driving me insane when I look at it too. But we'll just deal with that. So if you're watching the recording, just send me an email, and I'll send you out a copy of that. So, a couple things. So our third exam opened this morning, and it'll be due on Friday of this week. So make sure I would recommend starting it either tonight or tomorrow after studying. But try and take it early so that you can have multiple, since you have multiple attempts, if you try it early, then you can learn from your mistakes and do better. If you're happy with your score after the first attempt, no big deal, awesome, great. If you're unhappy, take it again, but study up. You can always email me. And if there's any mishap that you did, like typos, I can easily fix those. Otherwise, if it's something where you're like, I'm not sure where I did wrong, please send me a picture. That way I can see exactly what you did. And that way I can give the most partial credit too. And in case you don't know on how to do that, you have Canvas does have an app that you can download on any device. So in particular, you can get your phone and you can attach pictures. So you can take a picture of your work and then I can view it. That's the easiest way to get me to see your work. Ideally, just have it kind of well labeled. But yeah, the exam opened this morning. 90 minutes, 3 attempts. And you should be able to look back on it and see what you got right and what you got wrong. Try and figure out the mistakes made. Yes.
How many questions?
So good question. Great question. So normally all of our quizzes are 10 questions. Or sorry, all of our tests are 10 questions. However, I saw that there was one question on the exam. So just in case you did not know, I think we mentioned at the very beginning, but it's been a while. Math 120 and 120E are very, very we're trying to we try to coordinate those courses, meaning that they all kind of have to try and be in the same general structure. So I use a kind of a common exam that a lot of us use to make sure that we're measuring outcomes correctly and everything. That's what the main thing is the final exam, the final quiz rather. But regardless of that fact, one of the questions was finding the degrees needed for a pie chart, which I just fundamentally disagree with. So I removed that question. So there's only 9 questions on this exam. I'm even consider no, I'm not even gonna say it out loud because then it becomes law when I say it out loud. But so yeah, there's only 9 questions this time because one of them has been removed in an executive decision to not have to deal with pie chart BS. I am not part of the Math 120 committee, but I will be bringing that up whenever I can to say hey, I don't think this is. I would much rather spend time on I don't know, the mathematics of origami. I think that would be more useful than finding the degrees that are needed for a pie chart. Anyways, so other thing just as a note, so we are starting week 11, which means that we now officially have 5 weeks left. We have 5, including this week. Now, I know that's a long time. 5 weeks is a long time, but if you think about it in the number of classes, that means we have now started the 10 class countdown timer. Not including in 11 countdown if you're including finals week. But so 10 more classes of awesome Math 120. And then you're done for the semester. So I know, right? Without having a crossword every week. A crossword that we're solving. So anyways, eventually on that front, I'm pretty sure they haven't sent them out yet, but eventually they will start sending out student evaluation requests. And I'll mention again when that happens, but like, I'm so sorry. It gets to the point where they become very, very aggressive and won't let you do anything unless you actually say like, no, I'm not going to do the evaluation. And like, then you'll click on a new link and they'll say, do you want to do your evaluation? I have no control over that. I'm so sorry. I've actually asked our IT department if there's any way to like turn that off, and I don't think that there is. So anyway, so we had left off with z-scores and figuring out how the z-scores work. The z-score is a calculation that tells you, when you look at a table, the percentage of data values that are below your given data values when you found a z-score. Now, there's one other thing, which is the margin of error. Margin of error. So you'll see these things all the time saying that in a survey, 68% of people preferred Pepsi to Coke or whatever. And does that mean that everyone, like that 95% of everybody prefers Coke to Pepsi or whatever? Is that 100% accurate? No, because you didn't test every single person alive, right? You didn't go over to a baby and say, which one do you like more? So how certain can we be? That's what the margin of error is all about. So definition. The margin of error, which we are now going to write as MOE, is a bound around a value to account for the fact that we are only surveying a smaller portion of the whole. That's what a margin of error is used for, is like it's a bound, meaning it has an upper area and a lower area. Like that's what we mean when we say a bound. So if like if 70% of people like this and the margin of error is 10%, then you can assume that it's between 80 and 60% if the middle was 70%. The upper bound being 80%, lower bound being 60%. We'll see it in action in just a second. Now, how do you find the margin of error? There's a formula for that. Formula for MOE, margin of error, with what we say 95% confidence. That 95% confidence will show up in just a second, and it'll make sense in just a moment. But this is the formula for the margin of error with a 95% confidence. And what it says is that if N people are surveyed, the MOE, the margin of error, is equal to plus or minus 1 over the square root of N. And this is the decimal form of a percent. The decimal form of a percent. Now, how this formula comes to be is a little beyond the scope of the course. It's a pretty high statistical model and has to do with that 95% confidence interval. But regardless of how it comes about, that is the margin of error with a 95% confidence. So when we see the question when we see it in an example, you'll understand what I mean by a 95% confidence. So that is the formula. 1 plus or minus 1 over the square root of N. That is the margin of error as a decimal form of a percent. So when we're talking about it in the actual problem, we'll convert it to percentage form. So example. In a survey of 940 students, 68% said they liked the dorm food. And so this is exactly why we like, it's important to know the number of people surveyed, because the margin of error, I meant to mention this in my previous class, as n goes up, right? As the number of people you survey goes up, the margin of error goes down, right? Because the more and more people that you survey, the more certain you can be that most people like something or dislike something or whatever. So that's when you see it, like they say a survey and it says some outlandish measurements, we should say, well, what's the margin of error on that? And you'll see in this problem. So what is the margin of error on this survey? What is the margin of error? So I would imagine this would be much lower if, like, so CSN, we don't have a dorm room situation, but we do have a student union. And I imagine the percentage would be a lot lower than 68%. Boom, roasted CSN. Don't fire me. But they didn't really give any faculty any input on what foods they wanted to have at the union buildings, which bummed me out.
In the cafeteria,
Yeah, in the cafeteria.
they're all right.
So maybe 68% is okay. I gotta say, I don't like paying airport prices for Starbucks thing. That is problematic. Either way, don't fire me, CSN. I promise you I'm good. N is equal to 940 here because 940 people were surveyed. So the MOE is equal to plus or minus 1 over the square root of 940, which is equal to plus or minus 0.03261 on and on forever. So approximately 3.26%, plus or minus 3.26%. That's the margin of error. And so how do we use the margin of error? You find your upper bound and your lower bound first. So the upper bound, or I guess upper estimate, would be 68% plus 3.26%, which would be 71.26%. And the lower estimate would be 68 minus 3.26%, which is 64.74%. And so this is how we use the margin of error with a 95% confidence interval. So how the margin of error gets applied is we say we are 95% confident that the true percentage of students who like the dorm food is between 64.74% and 71.26%. That's what we can say. And if it's just asking for the margin of error, we just write 3.26. But if we're asked what it actually means, the answer is what I just wrote here. And so I'll let you write that down. There's a lot of words, and then we'll break down what this is saying. If I remember correctly, so I'm not a statistician, but if I remember correctly, there's a couple other versions of this as well. But this is this is the common one that we'll be using. So what it's saying, once again, is so we have this upper bound and this lower bound. That's the margin of error. It's saying that the true percentage of data. So we only surveyed 940 people. So like the incoming freshmen in dorm rooms usually is far more than that. There's usually like, I would guess like depending on the university, maybe 3,000, maybe 6,000 students going into the dorm rooms. So we've only measured a few of them. Maybe we only measured one dorm room and they have a not so great staff that isn't putting the TLC into those mashed potatoes that we deserve, right? Like when I was working at Starbucks, my frappuccinos were fire, as the kids say. I always had like, there was no, like when you drank that thing, no matter where you were in it, it was always blended. Like, you know how like some people, when they drink it, like it starts to become ice or whatever. Never happened with my frappuccinos. My frappuccinos were on point. So maybe they just didn't have me making the frappuccinos there, you know? So maybe if they surveyed my dorm room that I was working at, people would be like, oh no, the stuff is lit AF, as they say, right? I think I told you guys, did I tell you about the Blueberry Hill? Like I was my first semester here, I asked my students for good food recommendations because I was new to Vegas. And one person said Blueberry Hill or something like that. It said the blueberry French toast is lit AF, and I didn't know what AF meant at the time. I didn't know what lit meant either. But anyways, what this is saying is that we are 95% confident. We're pretty certain that the actual percentage of students who like the dorm food is somewhere between 64 and 71%. Based on the fact that we only surveyed 940 people, that's where we are guesstimating. Cool? Any questions on that? We can also work backwards. So notice it's a two-variable equation. There's the margin of error and there's n. So if you're given n, you can find MOE, but if you're given MOE, you can also find n. So here's another example. If the MOE of a statistic is plus or minus 5.85%, how many people were surveyed? So yes, we could create a formula to calculate this, but I want to do it another way. I want to do it by doing the algebra. Just good practice on being comfortable with our numbers and how to deal with them. So the margin of error is given to us as 5.85%. So MOE, geez, this thing does not have a battery life anymore. MOE is 0.0 plus or minus 0.0585. We'll ignore this. We'll ignore this plus or minus, and I'll show you why in a second. We're just going to ignore the plus or minus in the formula. And once again, you'll see why in just a moment. But the MOE is 0.0585. So in the formula, then we have 0.0585 is equal to 1 over the square root of n. So how do we solve for n? There's a lot of ways we could go about it. And so in mathematics, my thought is if I don't know what to do, I ask myself, what could I do? Maybe it'll work, maybe it won't. We don't know. But that's the fun, right? So what I'm going to do is I see a fraction. I don't like dealing with fractions, so maybe I should cross multiply. So I'll treat this as over 1 and I'll cross multiply and I get 0.0585 square root n is equal to 1. Okay, maybe a little more approachable. And then if we remember kind of the end goal of solving an equation, you want to get n by itself. You want to have n equals, or x equals, or p equals, whatever it may be. The variable equals something. So, and then we got to remember that we usually try and work from like the outside in. Like we take care of all the people, like when we're trying to clean up our house party, we get rid of the people we don't know first, and then keep our buddies around because they're going to help us out the most. So that 0.0585 being multiplied into the n probably needs to be taken care of first. So we'll divide both sides by 0.0585. To cancel it on the left, and you get square root of n is equal to, so 1 divided by 0.0585 is 17.094 01709. Something like that. $17.094017009. So now we've got the n by itself, but it's square rooted. That's not a problem though, if we remember that the square root and the square are kind of inverse operations. Just like if we multiply by 5 and then divide by 5, it kind of cancels itself out. If we have a square root and we square both sides, the square cancels out with the square root. And we get that n is equal to 292.205, but we're talking about people here, so we don't have 0.2 of a person, so we'll round down to 292 people. Any questions on this? I want to talk about a few things, but I like anybody questioning the math or anything like that. So the reason why I said we ignore the plus or minus, like we could keep that plus or minus through the entire time, right? We could keep that plus or minus through the entire time. But once we get to this stage, once we get to the squaring portion, there's an important thing that happens with squaring. Any number becomes positive when you square it, right? -1 squared is +1. -10 squared is +100. So that like if it was positive, it would stay positive. If it was negative, it would become positive regardless. So that plus or minus really doesn't play any role in this calculation. It's just for the forward direction. So that's how we found it. We were trying to figure out how many people were serving. And it makes sense. As the number of people goes up, the margin of error goes down more and more. So since this margin of error was larger than our margin of error in the previous problem, 3.26%, we should have surveyed less people, and we did. We only surveyed 292 people, whereas we surveyed 940 in the previous situation. Just as a fun little observation. That is the last bit of information for unit 3. And so we can get on to our little worksheet, unless there's any questions. Okay. Unit 3, bring all together. So, what was I say? Reminder about this little thing that I've created. This is meant to be kind of a, like, it's not a review so much as it is bringing everything that we've learned, trying to like kind of incorporate multiple parts into each question. So this should not be the only form of study. Like looking at this and saying, oh, I'm good is not sufficient. You should be looking at your notes, looking at your old quizzes, looking at your own homeworks, try and get some more practice. But we'll start working on it. The data set for this one is 44, 45, 50, 57, and 57, 57, so 3 57s. Then a 61, 61, 63, 71, and 72. That's our data set. Now, we're being asked to find basically everything. Find the mean, median, and mode, find a 5-number summary, then find the standard deviation, and find the z-score of 63. So, the mode is very quick.
Let's
The
go.
mode is very quick. Free points. Heck yeah, the mode. So with the mean and the median, we need to know how many data values are. So let's count them up. We got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 data values. So we'll write that off on the side, 11 data values. So for the mean, all we need to do is just take all 11 of those data values, add them up, and divide by 11. So 44 plus 45 plus 50 plus 57 plus 57 plus 57 plus 61 plus 61 plus 63 plus 71 plus 72, all divided by 11. Let's calculate that. Yeah, I did something wrong in the calculation. It's supposed to be a nice number. I forgot the 63. So I get what was it? 638 divided by 11, which is 58. That is my mean. The mean average was 58. Median, unless there's any questions on that, we'll go on to the median. So luckily for us, the median, this data set was already in ascending order from smallest to largest. So we didn't need to rearrange it, but just be on the lookout. Sometimes they don't do that. I hate when that happens, but sadly, I don't make the rules. Like Excel exists now, we can always just reorder a data set from an ascending order. But whatever. Yay, trying to keep students down. That's a good thing, right? No. But how do we find the median? This is 11 data values. It's not too hard to just bring it inward and find it. But what if this was more like 111? Then it would be a lot more tedious to do that. So we learned our trick. Remember, we divide the number by 2 to find half of the data values. And then depending on whether we get a 0.5 or a whole number, we'll do it. So for this one, I'll take 11 and divide it by 2, and I get 5.5. And when you get a 0.5 as your answer, the next whole number is your middle value. So the 6th entry equals the median. As a reminder, if there were 10 data values, so if you got 10 divided by 2, don't write this down, but if you got 10 divided by 2, you get 5, which would mean the 5th and 6th give median. So that was the trick. If you get so if your number is odd, you're going to get a 0.5. If you get like 11, 13, 27, if the number of data values is odd, you're going to get a 0.5 as your answer. So the next integer number is your median. If you have an even number of data values in your data set, like 10, 20, 55, 56, excuse me, or 110, whatever it is, then you divide by 2, you'll get a whole number. That number and the next number give you the median. So that's just that little trick that we learned. That'll be especially useful in question 3 once we get there. So the 6th entry is the median. I'm going to circle it up here. So 1, 2, 3, 4, 5, 6. So that 57 is the median. That is the median. 57. And last but not least is that quick one, right? The mode. which is 57 as well. Our set had that's the mode is the number with the highest frequency, i.e. the number that shows up the most, which would be 57 with a frequency of 3. Okay. That's the first part of this question, was to find the mean, median, and mode. The next part of the question is to find the 5-number summary. And we already found the median, so that's good. And the first and last numbers in the in the 5-number summary are really quick to find. So for the 5-number summary, we have the lowest, which was already given. It's just 44. We have Q1, which we haven't found yet. Then we have the median, which we found, which was 57. Q3, which we don't have yet. And then the highest data value is a 72. I deliberately made this question have 11 data values. Like I didn't just say, that's good enough, and I'll stop at 72. There was a reason why I did it. So I wanted to remind us of something. So one of two things can happen. Either the median is a number in your data set, or the median is a number that's taken by finding 2 numbers in the middle and cutting it right in half. If the median is a number in your data set, that is the direct middle. That is the identical middle of your data set. And as such, it is no longer considered part of the upper half or the lower half of your data values. So Q1, the first quartile, is calculating the median of the lower half of the data set. So if the median is actually a number in your data set, it gets excluded when calculating Q1 and Q3. Does that make sense? You guys remember that? So since 57, I know there are other 57s, but those 57s aren't the direct middle of the data set. So that 57 is excluded. When we're talking about Q3 and Q1, we're looking at these ones. And you can do it however you want. It's only 5 data values, so it's not too terrible to calculate, but to find the direct middle, but you can still do it with our trick. 5 divided by 2 is 2.5. So the third entry in either one is Q1 or Q3. So this is Q1 and this is Q3, 50 and 63. That makes sense? Any questions on that? However, if I just to mess around with things for a second, just to do something fun here, I'm going to erase this. Okay, what if I got rid of the 72 here? And my highest value is a 71. Now I have 10 data values. Right? So before I go off on this little tangent, does anybody have any questions on the 5-number summary? Okay. So this, you don't need to write this down. This is just an extra conversation. Now I only have 10 data values. So the 5th and 6th entry, which just so happen to do 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, and 6. So those are the middle 2. So the median is 57 plus 57 divided by 2, which is 57. That is the middle value. And yes, it is the same number, but it is now the direct middle. So this is these ones are used for calculating Q3, and these ones are calculating Q1. So even though, yes, 57 is including the data set, the median was halfway through. So it wasn't actually a number. It is, but it isn't, if that makes any sense. It was found by taking the 2 middle values. It just so happens the 2 middle values were the same number. So it is not a number in the data set. The median is not a real number in the data set. We found it by taking the two numbers in the middle. So when we're calculating Q1 and Q3, we still have to take this 57 and use it for Q1 and this 57 and use it for Q3. Kind of strange, I know, but that's just kind of an observation to make. Any questions on that? Is that cool? All right. So that was the second part, finding the 5-number summary. Now, the standard deviation, we can calculate the standard deviation on any group. We can, like, on any data set, you can find the standard deviation. I said find the z-score, and I want us to be cognizant of the fact z-scores can technically only work if you have a normally distributed data set. If your data is normally distributed, then you can find z-scores. So me asking for the z-score is actually kind of flawed here. I shouldn't be asking for it because this data is not normally distributed, but we're going to suspend that disbelief. So the next thing we need to do is find the standard deviation, SD. Which we abbreviate with a sigma. If you remember that massive formula, right? It's you take each number, you take its difference with the mean average, and square it, add all those numbers up, and divide by the total number of numbers. So in essence, to avoid having to write down 10 things, I'm just going to do, okay, so 44 minus the mean, which is 58 squared, plus 45 minus 58 squared, plus ... plus 71 minus 58 squared, plus 72 minus 58 squared, divided by the total number of numbers in the data set, which was 11. I'm doing the ... so that we don't have to write 10 of them. But I would still like us to all compute it if you have your calculator handy, just so that you can check to make sure you can enter it right in your calculator. The last thing I want to see is you guys plug this in and do all that work just to get it wrong. So practicing it is always very good. So I'm going to do that. I recommend calculating the numerator first, then doing it, like, do it in steps. So calculate the numerator first. So this is a long calculation. So I'm going to do this while sitting down. Bless you. I get the square root of 840 divided by 11. So let's make sure we all got the same number in the numerator. And if you did not get the same number, try again. And if it's still, like, because it's probably just a small error that you made, maybe, like, I actually noticed it while I was going through it, that I had, instead of written 61 minus 58 squared, I actually wrote a 60. And I corrected it. Oh, I love daylight savings time. I thought we were done. I 100% agree. And so the good news for everybody else is that, like, you guys technically gained an hour, right? If I remember correctly, because, like, what was 5 o'clock is now 6 o'clock, right? Wait,
What was 6 o'clock is now?
Yesterday, last night, Sunday, Saturday night. We had the switch.
It was funny. I would have
Wait, you
worked that
didn't
night.
notice.
I was like, would have worked that night, but they didn't schedule me, and I was so thankful. I was cheering.
So like, wait, so we fall back. So what was 6 o'clock is now 5 o'clock, right? So if you had to get up at 8, you're now getting up at 7. So it sucks for everybody, right? Sucks for everybody. We don't gain an hour. But being a parent, my son, he doesn't understand daylight savings time. I can't go up to him when he normally wakes up between like 6 and 7 o'clock. I can't go up to him at 5 in the morning and say, hey, daylight savings time happened, so you need to stay asleep an hour later. It didn't really work out. I tried it. So I put him in a cage for an hour. No, I'm kidding. Of course. But that's why I'm yawning so much. So hopefully everyone got 840 divided by 11. So that should be 8.73-ish. 8.738, so approximately 8.7. Let's just round to one decimal place. We'll call it good. The problem will usually tell you how many decimal places it wants you to round to. So that's the standard deviation. So the z-score of 63. If you remember the z-score, its formula is z is equal to your value minus the mean divided by sigma to figure out how many sigmas, how many standard deviations you are away from the mean. As I said earlier, like before calculating this one, technically speaking, you need a normally distributed set to talk about the standard deviation, or to talk about the z-score. But we're going to suspend that. So our data value was 63 minus the mean, which is a 58. Divide that by 8.7. And you get 0.5747 . And for z-scores, we usually round to the nearest tenth. So 0.6. And we could use the z-score table that's listed there. By the way, on the exam, any problem that uses the z-score or any table that you need, it will be provided. So you don't have to have that like on a sheet of paper to have. You don't need to have it on your phone or anything like that. It will be provided. So a z-score of 0.6 represents that 72.5% of the data is below it, and that's not 100% accurate because this data is not normally distributed. I'm just wondering if it's supposed to be distributed or distributed. Either way, doesn't matter. Tomato. All right. So on to question 2. So on a standardized test for her school with 527 students, Cindy scored in the 83rd percentile. What rank was Cindy? Okay, well, 83rd percentile, we need to remember what overall rank means versus percentage rank, percentile rank. Percentile rank, if you're in the 83rd percent, that means that 83% of students scored below Cindy. That's what the 83rd percentile means. So we take that 83% and multiply it by the 527 students. So 0.83 times 527 students gives us 437.41, so approximately 437 students below Cindy. On the totem pole, there are 437 students below Cindy. That is not her rank. So remember, your rank is based off how many people are above you, right? If you're in second place, there's one person above you. If you're in third place, there's 2 people above you. So in order to find her rank, we need to take the total number of students and subtract off the number of students below Cindy. So 527 minus 437 is 90. So that means that 90 students, including Cindy, scored above Cindy. So she's the last one in that situation. So she got 90th place. Does that make sense? So it's that there's that duality in percentile rank versus overall rank. Overall rank is counting down from the top. So if you're like you're looking at the people above you to calculate it, whereas percentile rank is looking at the people below you to calculate it. Does that make sense? Right. Question 3. I'm just going to do a rough sketch of the chart. So 1, 2, 3, 4, and 5, and then 15, 20, 11. No, not 11. 11. Nah, I'm mad at myself. I'm really mad at myself for that one. Okay. So when you see these types of charts in your homework and potentially on the exam, I'm not saying that there is one of these on there, but if there were, there's usually a quantifier, and then there's a thing that says frequency. The frequency is telling you how many times that number that it corresponds to occurs. So this is saying the following frequency table describes the number of attempts taken on a placement exam, and you're going to find the mean, median, and mode. So what it's saying is it says number of placement attempts and then frequency. So what that means is there were 15 entries of one attempt. So 1, 1, 1, 1, 1, 15 times, and then 2, 2, 2, 2, 2, 20 times, then 3, 3, 3, 11 times, and so on and so forth. That's how we interpret the frequency table. So there were 15 students who took it once, 20 students who took it twice, 11 students who took it 3 times, 6 students who took it 4, and 2 students who took it 5 times.
Why did that like
That's because I had screwed up. If you look at the actual like the handout, I did that on there on accident.
Yeah, that's why I'm asking.
I messed
I
up.
think it sounds so special.
No. Legitimately, it's just I was when I printed it, I didn't notice that until after I'd printed it. And they're getting they're like we had our printing budget cut in half, so I have to be careful.
Okay,
So I
I
did-
just thought they need special formula.
No.
Register this.
No, it's just because I was being silly in my notes. So that's how we read that frequency table. The frequency column is telling you how many times that data value occurs. That's how we know it. Frequency meaning the number of times it shows up. So it says to find the mean, median, and mode. So for the mean, all we need to do, we could go through and add 1 plus 1 plus 1 plus 1 plus 1 15 times, and then add 2 20 times, and then add 3 11 times. But it would be better to just multiply it by the number of times it occurs. So 15 times 1 plus 20 times 2 plus 11 times 3 plus 6 times 4 plus 2 times 5. Divide that by how many data values total? 54 total data values. We get that by adding up all the numbers in the frequency. So 15 plus 20 plus 11 plus 6 plus 2. And so we're going to divide that by 54. Now, I know a question that may be popping up in your head is, why didn't you do 1 times 15 plus 2 times 20 plus 11 times, or 3 times 11, so on and so forth. They are the same thing, right? Multiplication is commutative. 2 times 3 is the same thing as 3 times 2. But I did that deliberately just to talk about new math for a second. There are 15 groups with 1 test attempt in each group. There are 20 attempts with 2 in each group. There are 11 with 3, there are 6 with 4 attempts, and there are 2 with 5 attempts. That's how new math is kind of talked about in the earlier stages. And it is a better, like, I'll get off my soapbox here in just a moment, but new math, if you have any student, like if you decide to have kids and you do have kids and they're doing the new math and you're frustrated with how it looks, you can definitely talk to me. I'm happy to talk to you about it. I understand the frustration, but it is a better way of doing things.
I'll just send you,
yeah.
my kid.
Absolutely. If I'm still alive, if I like, I'm happy to do it. You can send an email to philip.cook@csn if I'm still working here. But I got into a Facebook argument long ago, and that's actually kind of basically when I stopped going onto Facebook. I stopped using it because a student, like a friend, a Facebook friend, so I'm gonna say a friend, was complaining about new math, and I had to be the warrior to fight for it. Because the people who typically hate it, the old way worked. 37 times 54, the old way works. Yeah, the old way does work. You guys know why? So like we go, okay, 4 times 7, that's 28, and put a 4 here. Or sorry, 2 here. And then 4 times 3 is 12, plus 2 is 14. Then we put a 0. You know why this works? Why it works? Why we're doing this algorithm?
Because it does.
Because it does, right? I asked him, he didn't know. I was like, here's your point. It's like, yeah, you were able to memorize an algorithm, not too hard. Like some people, it's not, it makes no sense. Like for some people who like to know the reasoning behind something and why it works, this is really, really confusing to them. So that was the whole argument that I got into. I was like, it's actually very intuitive. Once you see how they're working, what they're trying to teach, it actually makes a lot of sense. And so anyways, I'm off my soapbox. Thank you for coming to my TED Talk. Point being is that new math is actually trying to do something that is beneficial. Because so many students did not like the old way. We eventually figured it out with enough ruler hitting, but over the head or in the hand or whatever, but anyways, I'm getting sidetracked. So 15 plus 40 plus 33 plus 24 plus 10, divide that by 54, and you get 2.3-ish. Roughly 2.3. So this the mean average student took it twice and then started taking the third time and said, screw it. I don't want to take it. The hardest one in this situation, the hardest one for frequency tables, this is not too terrible. The mode is going to be really quick, but the median can be tricky. So the median, we have 54 data values. So yes, we could sit there and list out all 54 data values, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 2, 2, 2, 2, 2, 2, 2, and write them all out and then find it out. But that's actually going to be really, really tedious, and I don't want you to do that. So divided by 2, you get 27, which means the 27th and 28th give the median. So how do we determine what the 28th and 27th and 28th data values are? Well, we know that this thing is listed in order, technically speaking. It is listed in ascending order. You got the 1s, then you'll write the 2s, then you'll write the 3s, and the 4s, and the 5s. And so what we see is that the first the first 35 data entries. The first 35 data entries happen from 1s and 2s. The first 15 are 1s, then the 16th entry is a 2, 17th entry is a 2, all the way up to the 35th entry is a 2. So the 27th and 28th entries are both 2s. 27th is a 2, 28th is a 2 as well. If it had been that when we divided, we got the 35th and 36th entry, then we'd have to do a 2 and a 3 and divide by 2. But it just so happens, so the median is 2 plus 2 divided by 2, which is 2. I mean, you could just write 2 because it's the same number, right? The average of two, the same number is the same number. But just in case that ever happens, I would hope that if this does show up on the exam and what's it called? And the calculation ends up being right on that cutoff, that would seem very mean. That was really weird how it went. That was strange. Just gotta keep charging my battery. I said, yeah, what a concept. Okay. Any questions on how I found the median? It's okay if there were. Last thing, it's the mode, which is the quickest one. We just look at the one that with the highest frequency. The mode is 2 with a frequency of 20. And that is question 3. Done. Making good time. I even get out early. Don't count on it though. Don't count on it. We're not sure. All right. Question 4. This semester, Jeffrey got an A- in his 5-credit biology, a C+ in his 3-credit math course, a B+ in his 4-credit computer science, and a D in his 2-credit dinosaur class. Man, should have been spending more time on that dino class. It's way too important. Way too important to bring that out at parties. So part A says that he wants to be accepted into a program, and they say that they recommend having a GPA of 3.1 or higher. That doesn't mean you can't get in with a GPA of 3.1, below 3.1, but your chances are a lot better if you're at 3.1 or higher. Otherwise, you have to kind of rely on your extracurriculars and stuff. So the question is, if they were basing it purely based off of numbers, they weren't looking at anything else, would Jeffrey get in with his GPA? Well, if we want to know the answer to that, we need to find Jeffrey's GPA. So I usually like to make a chart, but you can do it all at once. So I say the grade, credit, GPA point. And then credits. Because the way GPA is calculated is each credit for a course corresponds to a GPA point. So a 4.0, like an A in a 5-credit class, weighs more heavily on your grade than an A in a 3-credit course. So he got an A- in biology, an A- on that chart that's provided. An A- is a 3.7, and this was a 5-credit course. Then he got a C+, which is a 2.3, and it's 3-credit math course. Then a B+, which is a 3.3, in his 4-credit computer science course, and then a D, which is a 1.0 in his 2-credit dinosaur class. So the way you calculate GPA is you take the GPA points multiplied by the number of credits that you got that GPA for, and then divide that by the total number of credits. So the total number of credits, 5 plus 3 is 8, plus 4 is 12, so 14 total credits. So we take 5 times 3.7, or you can do it the other way, it doesn't matter. 3 times 2.3 plus 4 times 3.3 plus 2 times 1.0, and divide that by 14. So if we calculate that, we should get 2.9. Aw, shucks. Jeffrey's GPA is a 2.9, so Prob's not going to get in. Prob's not. Prob's not getting into the program with a 2.9. He's so close. If he had just known that it's pronounced ankylosaurus instead of ankylosaurus. Fun fact, I did not know that. I've been calling it an ankylosaurus my entire life. You know, the one with the spikes on its back, like a plated back with like a hammer on its tail, right? Sledgehammer's tail. I actually called it an ankylosaurus, not an ankylosaurus. Now you get to be that guy at parties. So you're welcome. Now people will hate you just as much as they hate me when you bring that up at parties. I don't know how often ankylosaurus comes up in your conversations, but clearly not enough. It needs to be happening in every conversation. So based on the question that was asked, he probably will not get in. Now the part B, unless there's any questions on part A. Part B is asking that is saying that the mean average is the 3.3. So typically speaking, they ask like the students who are getting in there are getting higher GPAs. So the mean average mu is a 3.3 with a sigma, a standard deviation of 0.3. So what percent of students entered the program with a GPA lower than Jeffrey? So that's what we have to understand. The z-score for a value tells you the percentage of people scoring below you, or a percentage of data that's below you. So if we find Jeffrey's z-score for his GPA, we can then find the corresponding area or percentage of people who scored below him. So z, that's a weird z. Z is equal to x minus mu divided by sigma. So his GPA was a 2.9 minus a 3.3 divided by 0.3. That's negative 0.4 divided by 0.3, which is negative 1.33 repeating. So that's negative 1.3 approximately. For z-scores, we always round to the nearest 10th or first decimal spot. And you don't even really need to know that because the z-score chart that we're given only goes in increments of 0.1. So you'll just round to the nearest nearest 0.1. Nearest first decimal place, excuse me. So if you're looking at your chart from the table, a negative 1.3 is a 0.0968. So approximately 9.68% of students accepted had a lower GPA. So 10% of students accepted to that program had some pretty killer extracurriculars. So that's what the z-score does. Remember, the z-score, you get a number. That number tells you the number of standard deviations you are away from the mean. And you can use that with the z-score table to figure out the percentage of data values below the given data value. Any questions on that? All right, the last problem. In a survey of 1,550, so 1,550 babies with data normally distributed, the mean average height was a 49.5 centimeters. That's true, by the way. I had to look that up. Apparently, for males, it's 49.9, and for females, it's 49.1. So I just went with the halfway point. Statistically speaking, this is about 50% female, 50% male. So that's what I decided. So 49.5 with a standard deviation of 0.4 centimeters. How many babies in this survey were between the heights of 48.7 and 49.9 centimeters? So for question 5, I noticed, by the way, that 49.5 is precisely one standard deviation above the mean that's given. And 49 or 48.7 is precisely 2 standard deviations below the mean. So I'm thinking this has to do with section 3.5. We draw a normal curve, remember, and we had that thing where we separated based on the 68, 95, and 99.7 rule, or the empirical rule. So I'm going to draw a normal distribution line, or curve rather. And so right in the middle of our data set is that 49.5. Right in the middle. And then going up 1 standard deviation and below 1 standard deviation. So up 1 standard deviation would be a 49.9. And 1 standard deviation below would be a 49.1. Then 1 more standard deviation would above would be a 50.3. And going 1 down below would be a 48.8. Sorry, no, 48.7, excuse me. And last but not least, 1 more data set out, would be 50.7 and a 48.3. So, the way that this thing worked is that 68% of the data approximately lies within 1 standard deviation of the mean average. Approximately 95% of the data is within 2 standard deviations. So that green line would represent 95% of the data. And then that pink line, everything on the inside of that would be 99.7. And then there's the outskirts. And then what we realized is we could break that down into percentages. It was 34% here, 34% here, then 13.5, 13.5, then 2.35, and then 0.15% on the outskirts. And please don't have that memorized. You can use use a chart to figure that out, like knowing the differences in sizes. But that's approximately the percentages here. Any questions on that? The wrong thing. So what's very, very nice is that 49.9 and 48.7 lie directly on standard deviation points. So what we're asking for is this part of the data right here, this chunk. So all we need to do is add up the percentages. So 13.5 plus 34 plus 34 should be 81.5%. Now, John Doe student boxes this as his answer. And why is John Doe student wrong? Exactly right. Now, granted, if you entered 81.5 on the exam, it would mark it wrong and give you a 0 out of 5. However, if you emailed me on that situation, I'd probably give about 3 or 4 of the points back because you're so close. The only thing is it's saying how many babies, not the percentage of babies. So it's just a verbiage thing. So we want 81.5% of the 1550. So 0.815 times 1550, which is equal to, so 1550 times 0.815, which is 1,263.25. But we're not talking about like the measurement of a baby in utero, right? Like that 0.25 doesn't count. So it's really just approximately 63 babies. Okay. Any questions on that? And that just so happened to be able to be worked out because the measurements that they wanted me to find. Like now, there's plenty of questions we could ask about this one. We could say how many babies were taller than 49.9, which would be this percentage right here in pink, right? Or it could say how many babies were 49.5 or below, which would be this area that I've kind of highlighted in green and so on and so forth. So it's all about adding up those percentages, but that's only if the numbers lie on a sigma, on a decimal, like on a integer multiple subtraction or addition of this of your standard deviation. If it had said like what percentage of babies or how many babies are between 50 and 49, then we'd have to use z-scores because those numbers don't lie perfectly on one standard deviation or two standard deviations, three standard deviations above. Does that make sense? So, okay, guys, that'll be all the questions that I have. Does anybody have any questions before we call it a day? It's okay if you do. Yeah, you can keep them. All right, guys, and that'll be it for today. We'll start up chapter 4 on Wednesday with 4.2. Please take care of that exam. Ideally, try and finish your 3.6 homework and quiz beforehand, because that's just free practice. And if you have any questions, feel free to email me. Any issues with your exam, please feel free to talk to me. I'm happy to meet you before class, after class to figure it out, or during my office hours. Otherwise, you have a great rest of your day. Good luck on the exam, and I'll see you on Wednesday.